Welcome back to Area Diesel Service. So today we've got another exciting collaborative effort with fellow YouTube creator Diesel Creek. Inside of this box is the pump and the injectors from Matt's 1980 AutoCar project. If you've been following along over on his channel, he bought this truck a couple of years ago, kind of a cool, old, gnarly looking rig. The story was that this truck spent its life somewhere local to Matt in, I think, like a strip mine. It was like a service truck for the Silver Spade, which was kind of a legendary shovel.
Designed by legendary manufacturer Bucyrus Erie, the gigantic shovel was born under the reference 1950B. Built on site, the Silver Spade went into full production towards the end of 1965 and then spent most of its working life strip mining in southeastern Ohio. It took 14 separate motors for the shovel to operate, thanks to a 7,200-volt electricity supply. It stood at a towering 222 feet above the ground, taller than a 12-story building, and it was as wide as an 8-lane highway.
Great big monstrosity of a piece of mining equipment, and this AutoCar ConsTrucktor was its support vehicle, or at least that's what we've been told. Kind of a neat story. The plan with it for Matt is to make it kind of his daily driver, haul around his machines and equipment. But the problem is it was factory equipped with a small cam Cummins rated at 230 horsepower. He actually found another engine, a big cam, and we looked at the serial number and arrangement of that engine. That engine was built in 1990. It was factory rated at 315 horsepower, and we can tell by the arrangement of parts that someone's got it turned up to about 400 horsepower. It sounds like the story Matt was given was that somebody had it up around 600, which is kind of danger zone. At least that's our opinion. You're looking at the combination of the fuel pump, the injectors, and the turbocharger. We believe it's around 400, which is pretty safe, reasonable range for that engine and for what Matt intends to do with it. The current status of the engine, so again, Matt bought this Big Cam engine off the internet somewhere. It was from a rollover accident, so he tore that engine down. He did find some internal engine damage. We actually shipped Matt a complete out-of-frame overhaul kit, and he's currently in the process of rebuilding the engine. While that is happening on Matt's side of the situation, the pump and the injectors came out here. Theoretically, these are in good condition, but it's kind of a while we are there, preventative maintenance, ensure that the calibration is worthy of this 400, potentially try and tweak it a little bit more. This is a Cummins PT pump. We'll open it up and have a look, but you may have heard about the button, right? Everybody upgrades their button, and this is a button out of a Cummins PT pump. We'll kind of show you where it fits, what it does, how it works. Keep in mind, this is one of the many things that I'm not really qualified to speak about. I understand a little bit of how they work, but I'm certainly not the pump technician. We're going to open this up, have a look, see what we got. So we've got it unboxed, scattered out, a couple initial observations. This injector, don't know when or where that happened, but it's got an O-ring cut on it. That was the only real thing I saw as we were unboxing. Got a throttle lever loose in the package. No big deal. So one thing I can tell is that someone has been here before us, and I can see where they've taken a number stamp or a letter stamp and X'd out some of the identification numbers on the housing. So someone's been in this pump. Matt sent me a picture of a button, so I'm assuming he's had this pump open and got the number off of the button inside of this pump from the engine serial number that he provided that this pump came from, and the button that was inside of the pump. And now, after seeing that someone has stamped out some of the numbers and re-identified it, someone's definitely been here before us. So you don't ever know what you're going to get. This is a Cummins PT pump. And a little different in that Cummins manufactured this, so a lot of the fuel systems you've seen us work on before are from people like Bosch or Stanadyne or Denso, and the engine manufacturer purchases and equips their engine with a fuel system from a fuel systems manufacturer. Cummins in this era was manufacturing their own fuel system. Caterpillar did a lot of their own fuel systems. This is a Cummins creation. PT pump, standing for pressure and time. Effectively a variable pressure supply pump. Kind of the original common rail, if you will. And this thing is driven by the engine right here. And based on effectively the calculations that are happening inside of this pump, it varies the output pressure being supplied to the fuel injector. The fuel injector is a mechanical unit injector, so it's driven off of an eccentric cam lobe and a push rod and a rocker arm, and it's mechanically being actuated and pumping the fuel through the injector into the combustion chamber. The PT component, pressure and time, operates on this inlet screen, and behind it is a specifically sized metered orifice. So given the amount of pressure that the pump is producing and the amount of time that the injector exposes that supply pressure to the business end of this injector, dictates how much fuel gets charged into it, and then when the plunger comes down, how much fuel gets fired into the cylinder. The pump knows at a given RPM how long that charging port will be exposed, and it's varying the pressure to increase or decrease or meter or govern the amount of fuel that's being injected into the engine. This is effectively a pressure bypass inside of the pump, and when we get into this, we'll try and show you where it fits and what it does. It's effectively one way of increasing the pressure that this pump puts out. If you turn up the pressure and the amount of time stays the same, then more fuel gets fed into the injector, more fuel gets charged into the cylinder. You have to be cautious though. Right, you can't do that at idle, or the thing will idle at 2,000 RPMs or run away. It's a pretty neat injection pump, in my opinion. I like the way that this was engineered and designed, especially given the era that this thing came to exist. Engine driven here, and there's a tack drive here, so you can see as this turns, it turns that, and it'll go to a cable driven tachometer. The back of this pump here is a gear pump, so fuel inlet from the tank. This is a diagnostic port where you can check how much vacuum or draw the gear pump is pulling from the supply system. Gear pump in here drawing fuel from the tank. There's a return port here for excess from the gear pump. There's a return port here, which is excess from the pump body. And then this is shut-off solenoid, electromagnetic shut-off solenoid. You apply voltage here. And then there's a mechanical, you can't turn it, but there's a thumb screw here where if you lose power or your system, you can still turn the engine on and off mechanically with that screw. This is an AFC type pump. They've got a plug in it. So AFC is air fuel control. Before the turbo spools up and feeds air to the engine, if you put this thing on the wood, it's going to give the engine a bunch of fuel. Before the turbo spools, there's not enough air to burn that fuel. That's why you see that initial puff of black smoke when someone gets after it in a diesel engine. The air fuel control was a very early emissions component, and it basically held off that fuel delivery until the turbo come up and provided enough air to burn it. No big surprise, the air fuel control is blocked off. They've probably got a plug inside it holding it to full fuel. This is throttle. This is the throttle lever that came loose in the box, so you can see that that operates from the foot feed. There is a set of flyweights in this pump. As the engine turns the pump, when we get inside it, we'll show you a better shot. but there's a set of flyweights that move some rods that uncover and cover different passages inside of the pump. So based on input from the throttle lever or the foot feed, and based on input from the engine RPM, and specifically the flyweights in the governor and the button and the springs on the back side of it, this pump has the ability to fluctuate or vary its output pressure. It's a pretty elaborate system on the inside. I won't pretend to try and understand all of it or be able to explain it all to you. That's basically what it's doing, is fluctuating or varying the amount of pressure that it's putting out. When we get back into the room and get it scattered, we'll show you some of the intricate inside components and kind of how they work, but that's about as much as I know about it. These injectors, we actually do not rebuild these in-house. We stock these as an exchange item from a variety of different suppliers. We talked about kind of how they work. Again, they're fairly simple. Basically, this is a spool valve, and there are some springs inside of it that hold it in a particular spot. And again, it's camshaft and rocker arm actuated. Depending on where that spool lives in the body of this injector, pressurized fuel comes through the metered orifice, charges up the ports down here. When the camshaft comes around, this thing pushes down, squeezes the fuel, injects it out of here into the cylinders. We are going to provide a set of injectors back to Matt for this engine, but we won't really have any footage showing how we do them because we don't do them in-house anymore. We used to back in the day, but not so much anymore. That's where we're at. We're going to write this thing up. We're going to tag it, ship it back to the fuel shop. The technician that does PT pumps is a little camera shy at Area Diesel, so we're probably going to do one of those update style, follow the process type of videos. We'll try and get some footage on the calibration stand showing you how we verify and calibrate these pumps. And then once we get through all that, we'll meet you back up here and we'll wrap it up at the parts counter. So we'll bring you along. So we've got Matt's pump torn down. We've got everything cleaned up, and we've made some initial observations. Everything looked pretty good. We believe that this was probably a perfectly fine and functioning pump. We can see that, as suspected, someone has been in before us and made some modifications. We'll kind of walk you through what that is and what we're seeing. But everything looks pretty good. Shouldn't have any issues. We'll kind of show you what we've seen, and then we'll take you through to some of the next steps. First thing, this is the tach drive. So this is the gear outputs to the tach. So we showed that at the counter. That basically fits in there. This shaft, I don't know if it'll pick it up, but you can see that that's kind of boogered up right there. Pretty standard failure, no big deal. That's part of the normal kit. We talked about the flyweights inside of this pump. This is hooked directly to the engine, and this gear turns that gear. And this is the flyweights inside of this PT pump. As the pump turns faster and faster, centrifugal force throws these weights out, and that operates on this plunger. This plunger is a precision fit into the housing here. And this is some of the passages that are being blocked and opened up as this pump's doing its thing. And this shaft is worn. You can kind of see the dull finish on it there. So this plunger will get resized and replaced with a new one. And then the throttle shaft, you can see very scarred up there. And we actually had to cut it apart to get the fuel screw out of it. So the fuel screw goes down inside the shaft. There was a tamper proof on it that fought us coming out, so we had to hack it apart. Pretty standard though. We always replace throttle shaft with new, and it also gets resized into its bushing here. Shut-off solenoid. So you probably won't be able to pick it up on camera, but this needs to be perfectly flat across this surface here, and it's wavy. You probably can't see it, but I can definitely pick it up with my finger. You can kind of see a pit or where
fuel has potentially eroded that surface. Electrically still functioning and would probably be fine to go again, but we don't like it. We're going to replace that. Gear pump we spoke of at the counter was fine. Again, the drive on this thing, this is the Lovejoy that comes off the engine. This is the gear that turns the counter shaft, that turns the flyweights, and then the gear pump is splined in there. So the gear pump is a direct drive off of the engine, and the gear pump housing, everything looks and checks out very good there. Gears are perfectly fine. We talked about the air fuel control, the AFC being blocked off. This is the dummy plug that we suspected we would find inside of it. So it just holds the AFC wide open like you're getting max boost all the time. Again, the AFC is there to kind of hold back fuel until boost comes up, but that's been modified in this pump. It's set for full fuel as soon as you ask for it. And then this is the air screw, and you can see someone has ground the tip off of it, which again doesn't let the pump limit fuel before boost, which is pretty typical of these old dudes. And the button that we spoke of at the counter, so this button has a number on it. This one is a number 15 button, which is a 25% fuel delivery increase over the stocks. This thing was originally fitted to a 315 horsepower engine, and based on what we've seen with calibrations, buttons, injectors, and turbo, the arrangement that they've got this thing put together in should be about a 400 horsepower engine. We've got some new parts spread out over here, standard kit, new solenoid, gaskets and seals, shafts and bushings, right? Everything that always goes into a standard PT style pump overhaul. This particular housing, we're going to take you back to the machine shop, and we're going to show you some of the process for reclaiming this. Fitment on a couple of the shafts is pretty critical. Minor machine work and honing on that. We'll take you back, show you some of that. We'll show you some of going back together, calibration and verification, and that's about it. This thing is relatively simple. I mean, I certainly couldn't sit down and build one, but as far as some of the pumps that we see here, this is basically a variable displacement high pressure pump. No cylinder specific delivery. This is just a supply pump. We'll bring you to the next step. So we've made it back to the machine shop. We've got the main housing chucked up in the Inco, right? So just kind of a typical Bridgeport style mill. We've got a fixture plate that is set up specifically for this operation. The main housing has a couple of locating dowels in it. The fixture plate is drilled for those dowels. Main housing pinned and set up on the fixture plate, and then we've got a shell mill, and we're getting ready to skin this surface right here. This is where the magnetic filter screen and the shutoff solenoid, and then there's a couple of plugs here. But this surface is pretty critical. Where these O-rings sit, this surface always kind of erodes, and in order to ensure a quality repair and a pump that seals up, we need to skin this off. I'll jump out of the way. We usually take cuts of about 5 thousandths. We'll reach down, touch off, and then we'll dial in 5, and we'll just hand feed across it.
We're gonna go down to where it's just touching. You see it scratching that? Take it 5 more thousandths.
There we go. So we got our sealing surface skinned off. We're going to move on to the next step. Again, main pump housing. We're back at the sun and hone, and there's 2 different bushings we're going to hone here. This is where the throttle shaft goes through the housing, and there's a bushing here that wears, and if it's too scored up, you'll actually bypass some of the governed fuel. Critical dimension here. The other bushing is down inside of here, and this is where the governor plunger enters into the main housing. Again, critical surface there. and we're going to hone both of these on the sun end to make sure we've got a good fit and a good finish. Kind of a dirty manual job, a lot of touch and feel by the operator. We're going to watch the expert hone both of these, and then we'll meet you back in the build-up room. All right, so first up we're going to do throttle shaft. Power up the hone. Got the honing oil, cutting oil coming out, so we'll give her a little bit of pre-lube there. That top wheel adjusts how far the stone sticks out on the tool, on the cutter, and then he's got a foot control, so he's kind of squeezing on the foot control to feed out the cutter. So doesn't take much. Give a little shmoo basket inside the shmoo bucket. Get all the cutting oil off. There you go. Honed and ready to rock.
I'll start with this one, you know. And I'll just see if it fits in there. And that one fits. So I'll go up a couple sizes to 7. And that one's getting rough, so that one didn't fit, so I go 2 sizes back to a 5, and that would be our throttle shaft. And same with the plunger. I got all these different sizes. I'm gonna go to one. That one doesn't fit, so we try the next size down. That one fits, so we go 2 sizes down from that one, and that would be our plunger right there. Make sure it goes back and forth. You're good.
There we go. That's how we fit them. Find the one that fits tight and go 2 sizes under, and that's the proper clearance for your shaft and plunger. We're back in the build-up rooms. We have cleaned everything again after honing, done a more thorough inspection of all the components, particularly those that are going to be reused, to make sure that everything is going to be good. We've got our new components staged in our box here. Everything that we're going to reassemble scattered out on the bench. We'll probably start on the gear pump end of the situation, pulsation damper, and we'll bring you through some of the reassembly. Probably won't capture the whole thing, but we'll show you some of this thing going back together and maybe try and hit on some of the functionality. And then once we get it built, we'll show you some of the testing and calibration of this pump, and then we'll meet you back at the parts counter.
Like dipping in this calibration fluid. Get lubed up a little. Make sure it's turning. Yes, and all in there. That together. Everything. Make sure it's turning.
Is that the fitting you said wasn't in it when it came in?
Yeah, it didn't come with one of these, but it's just a return fitting. It's a check valve in there. So that part's done. We'll set that to the side. So I'll do this. Got this plastic over.
So this is a damper. So because it's got a gear pump that feeds this thing, and the gear pump can kind of have pulsations and pressure, this damper is in series to kind of to dampen those pulsations, so thus the name.
Put that together. Find me a couple bolts to use.
So solenoid would generally be next, but again, we're replacing it, so
That's it. Then I'll move on to the front cover. New seals, new bearings, new shaft.
So the next step is the front cover, and part of this process is going to be to replace the input shaft and the bearings. So we're going to take this out to the press it apart, basically saving the gear, and we'll put a new shaft and bearing, and then we'll bring back in here and put the front housing back together.
I'm gonna put this seal in there. Start that in.
Blammo! That was that was your bearing exploding in the press.
We're going to reuse that. Reuse that. And we'll reuse that. This gets replaced. This step, I'm going to put the bearings in. They got some numbers on them. I usually like to keep that on top. I'm going to press the shaft in. Special tools in this thing.
I got all the good out of that one.
Yeah, been used. We got all seals in.
Shafts, gears, bushings.
Good. Got one in the keyhole. Okay.
So that helical gear, that drives the tack. Key to the shaft.
Okay. Now, I'm going to take this tack drive and press it apart. Just got this bolt here.
That's what you're after.
Make sure it spins freely. Give it a little lead. Okay, now you're gonna press this back on, and I use this little shim up here. Okay, about 10,000 for the shim. Put that on there, just give it a little extra. Push it down just a little further. Okay. should be good. Good. So it's going to go through here and slide into that gear. We're just going to tap it in until it gets flush. You hear it. There we go. There we go. All right.
Okay, so drive shaft, tack drive,
All right. So
seals.
It's got this little spacer that goes in here. And a little seal. This the same thing, just tap it right here to be flush. There's the nut for the tack. Bingo mango. Gear on. Well, it went on pretty easy. Sometimes I gotta press that on.
Was that keyed to the shaft?
Yeah, that goes right on that key. This is probably supposed to be torqued. That's the front cover.
So there is a gear pump, dampener, and the front drive housing and assembly ready to go.
Finished doing the plunger and the throttle shaft, and then we're gonna assemble everything that I built onto this. So I gotta go out there and press this collar on here and then push this in. Press that on. And this is the part that sometimes it'll get cocked in there and act funny, but oh, I got lucky. That's it. It'll start wearing right here, and that's where these ride on that, so you don't want that wear there either. I'm gonna put our little O-ring. We got a lot of O-rings and stuff to put on when we start building this. This is the fuel screw. If I can get it on there. Okay. Got the littlest O-ring out of everything. I'm gonna put a little that shit on there. Okay, this goes down into here. And we're gonna screw it till it covers about like half of that hole. That's just a good starting point to.
That's part of the calibration.
Yeah, for when we calibrate it, because open the hole more, it's going to need more fuel. Close it off, it's less fuel. But okay, we're good. So cover, just starting to cover that hole. Okay. It's got two notches on here. Always use the one on the right, otherwise your whole port won't line up in there. So you put this on. Line up with this hole on the right. We're gonna run this down. Gonna run this guy down until it hits. It's right under that hole. Then I'm gonna move it up to where it starts going in a little bit, so I know it's in that hole. Okay. There's another one of these. Get that. Just go ahead and put the O-ring on. Okay, that's the throttle shaft. One of these didn't come out, these set screws that go in here. I like to put them in first because the throttle shaft's not in your way when you're trying to put them in there, basically. This one come out of this side. So I'm just gonna take it back in, right? Kind of reversing it back in there.
So those are stops for that doohickey you just clamped onto the throttle shaft.
Yeah.
As part of the calibration or adjustment.
Right, yeah. I'll have to adjust them to where they need to be, but for now we're just gonna set it in there about like that. And this other side, it didn't come out, so I'm using a new one. So
So did you have to drill it out, or what do you mean?
It was sheared off on the side, and it was just poking in like that, so I had to just grab it and start turning it. It was a little stuck, but it came out. Didn't have to drill nothing, luckily. So we're just going to set that in there too, like about like that. Those are just starting point. I'm going to take this, put a little lube on it. Also, I'm going to dip it in the calibration fluid to lube it up. And we're going to set that down in there. Okay, then you've got a little C-clip that you're going to put on this end of the shaft so that it doesn't come back out.
You can see it just barely protruding down in there, so he's going to put a retaining clip on it.
Okay, you just want to make sure you don't have too much play where it's going back and forth. Pour that O-ring out real fast and it looks good. So. Once we get that on there. Okay. Once again, lube it up. We're going to lube everything up. And that goes in here. And that's your no air screw. This one's actually not doing anything. It's just going to plug that hole from coming out this way. Screw it down so where it's below that, because there's a cover that goes on there. And put this nut on. Usually I wouldn't tighten this down because I'd have to adjust it, but since this one ain't doing nothing, I'm just going to tighten it down. Okay. Next I'm going to I usually use this solenoid. I'm just going to set it down on here and make it sit even like that. Then I'm going to take the plunger, lube it up, make sure it's free moving in there. And I got the weight set. This is the weight assist spring and shims. And I'm just going to put them in just like I took them out. I'm not going to change nothing. Goes on there like that. And it goes into this hole. Like so. Okay, then I'm going to do a little balancing act here. I'm going to line this up to where it's sitting on there, if I can. Okay, and then I'm gonna grab my gasket over here. Put this gasket on.
Trying to give you an idea of how this thing works. So we looked at the screw in the throttle shaft that was covering and uncovering one of the openings in the shaft. And then this is the control rod, and you can see it's spring loaded. We'll show you in a little bit. The button goes on the other side of that. So, and then the flyweights go over this. And basically a combination of where you've got the throttle shaft positioned and its openings and the adjustment of the fuel screw down inside of it, as well as the depth of this control rod inside of the housing there based on the flyweights and the button on the other side of it. This pump is effectively kind of restricting and opening some passages, and that is really how it's achieving variable pressure. That's a pretty poor way of explaining it, but that's how I understand it. Put the rest of it together, and then we'll take you to the other side and show you the button side of things. So.
And that's going to slide into that hole to keep it steady where I want it. Okay. Just like that. Alright. So we're in. Now I'm just going to grab a couple bolts and start pushing it together. We're only going to put 4 bolts in right now in case we have to take it back apart or something. Just less we have to take apart. This hole over here actually goes into the AFC, which it's not working on this pump, but we always put a bolt with a rubber gasket on it just to make sure the air doesn't leak out of there. you can't see it probably, but you can feel it in there. It's a plunger. And that's what the spring packing button's gonna sit on in there.
The different number buttons basically is
This spot on it.
yeah, and that's the surface that the fuel is operating on. So if they make that smaller or bigger, it's allowed to push the button softer or harder against the spring pack in there. The smallest button is the biggest power.
For a given spring force acting on the button, increasing the recessed area reduces the pressure at which the fuel begins bypassing, thereby lowering the supply pressure. Decreasing the recessed area will have the opposite effect, that is, fuel will begin bypassing at a higher pressure, raising the supply pressure.
Critical part of the calibration. So we looked at what this pump part number called for by the button, and then we can tell that the number on this button, I think we said, was 25% more pressure than the factory button.
This has a buttload of shims on it. So he's probably got his RPM set up a little higher too, honestly. I'm not sure. Probably something you want to ask.
He'll be good with that.
He'll be good with a lot of RPMs. Okay. So there's just a little shim down here. Or, I don't know, it's not a shim, it just, what the spring sits on, I think it's just to eliminate wear. Then that's the idle spring. And then you have your button. Okay, so we're gonna slide this in this tube. Now that's going against the plunger. Okay. Then we're gonna have our spring. And this is our stack of shims and a spring seat, basically. Which you can see that's excessive. It's kind of binding up because it's got too many shims on it. You see it's sticking up higher than the spring seat. We can always try to put them back in later. There we go. Okay. Took me a little bit. Alright. Next is a gear pump. Make sure it's turning. Get this special gasket. It's actually metal. Okay. Maybe even get it wet a little. Slide it down in there. 4 bolts that go. Hold it down. These are all torqued to 144 inch-pounds. Kind of do a cross pattern. Change this O-ring on here. Gotta put this on first, otherwise you won't be able to fit it on there. Okay, remove these. Gotta put these 2 bolts in. They're also everything on here is 144 inch-pounds. Now the pulsating damper. Put the O-ring in there. Give it a little something to stick to it with. After you put that on, you're going to want to make sure it still turns. A lot of these will lock up after you tighten the gear pump on. This one turns pretty good. Got lucky.
What do you do if it locks up? Take it back apart?
Yes, you gotta figure out what's holding it up. Could be a lot of different things. So we're gonna stick this on here. Also just with 2 bolts, because if I gotta reshim it or anything, I'm just gonna have to take this back off. So we're not gonna put all the bolts in it right now.
So this is something you can remove while the pump is on the engine if you want to swap the button or shim the RPMs up, or
Right.
pretty common modification.
I'm gonna stick this filter in. It's hard to get real tight with this, just a screwdriver. So what I do, I put it in the vise here. Just turn it on to get as tight as I can. So that's probably good.
Click.
Click. This is usually the AFC side. There's this little spring underneath of the AFC barrel, which we got this plug, so we're still going to stick that spring in there. Move this up. Push it down in there. Then we got the C-clip. Kind of bent up a little. Hope it'll work. Okay. I get myself a one of these. Voila.
So if that thing was functional, there'd be a boost tap on this. So this cover goes here, right?
Yeah.
Yep. So that would be boost coming from the engine, and there'd be a diaphragm, I assume, in here. And then this dummy plug would be, what would it be? It wouldn't be a plug.
Barrel with a plunger and the diaphragm's hooked to it.
Okay. So all of that, so this is never going to move because of this C-clip. It's just plugged wide open.
It's just plugged.
In a functioning AFC, boost pressure would operate on a diaphragm, and then there'd be another rod, and
It'd be like,
there you go.
this would be the barrel that went in there, and this plunger,
Yep.
and it would
So boost pressure
flip this
would,
on it.
yep, boost pressure would move that up and down, and that would add to the variable pressure output of this pump. So it'd be a third leg of things to consider, but null and void on this one.
Okay. We're still going to use this for a gasket. Put this on there. Find some bolts. So normally the boost would hook up and go into that, but this one has a plug in it also. So they're not going to be hooking any kind of air up to it at all.
So on pumps that don't call for AFC, is that feature not machined into the housing, or is it just totally blocked off with a plate? Or
Yeah, some of them just have a flat plate right there. It
Okay.
just covers. It's just a cover.
I got a brand new solenoid assembly, but it's not his work, and because he's got to give his guarantee on this work, he's going to take it apart, just ensure that he likes it, make sure they got it put together correctly. So it's a brand new part, but it's our name that goes on it out the door.
Okay, this is nice flat. See, I don't like that. Probably gonna put a new one of these on there.
Got a big wave in the. Is that a gasket or what is that?
It's actually the plate that the magnet sucks it up and allows fuel to go by or shut off.
All right, so this come out of the brand new solenoid. You can see that wave in it, and that doesn't meet the standard of the trained expert here. So we're gonna throw that one away. I actually pulled one out. This is a used one, but I guess that's part of what you're getting at Area Diesel Service is a
It'll serve its purpose.
trained expert. He knows that used one is significantly better than that brand new one. So that's what he wanted to verify. Glad we did. So if that solenoid can't pull that shut in there,
Won't shut off.
it won't. Yeah, the engine won't shut off. So if you want If you want to frustrate a customer, send them a rebuilt pump that doesn't shut off, because that'll sure do it.
I'm gonna charge this 12 volts. Put it on there. You should hear a clicking noise. So that means it's working. Well, we're gonna put it on. Put these 2 bolts in here.
Was it a 12 volt?
It's 12 volt. It says on it. Okay, this goes on right here, right on top, facing towards the back.
So 12 volts turns fuel on, and if that's an issue, then that thumb screw is for like manual override, isn't it?
Yeah, if you turn this all the way in, it's pushing the plate manually, so it'll keep it running too. And when you take charge off, it should essentially die. Okay, now that's our pump, and we're ready to run.
Out of parts.
Out of parts.
High atop the list of things that I'm not qualified to speak about is the calibration process of this Cummins PT pump. I'll do my best to explain what's going to happen here, and then I'll step out of the way. We'll get some footage of the expert actually calibrating this. Effectively, what we've got, this is an electric motor behind here turning the pump. And we've got a dial down here that we can crank up, and we can fluctuate the speed at which this pump is being turned. We've got 12 volts going to our shutoff solenoid from our power supply up here. And then we've got some gauges hooked up so we can kind of monitor and calibrate this pump. This is fuel pressure, and we've spoken about in its most simple definition, this is a variable pressure supply pump. Roughly speaking, in its stock calibration, at idle you'd be about 37 psi, and full load you'd be about 164. This thing's been turned up about 25%, so perhaps 200 psi at full load. We also have this gauge. This is your boost pressure. Again, we're blocked off, so we won't be using aneroid pressure. Fuel temperature, so we've already gone through a warm-up phase. The stand and the pump are at operating temperature. And then we also have vacuum restrictions. This is effectively the restriction from the fuel inlets. What type of restriction are we getting from the tank and from the filtration system? And we're going to replicate that on the stand to make sure that this pump can draw through the tank, the plumbing, the filters, etc. Pressure, obviously a critical component of calibration, and then the other one is flow. So this is a flow meter here. Depending on the step in the calibration process, we'll be taking different measurements. So 3969 spec pump, that's the calibration code. He's got a note, we're going up 25%. The different things we're going to look for. This is your full load, 164 psi at 2100 RPM, and then we're looking for 482 on the flow meter. At idle, we're actually not going to rely on pressure, we're going to rely on flow. So we know that we should be about 37 psi at idle, but the best true way to calibrate an idle is going to be with flow. What you're going to see, we'll fire up the stand, we're going to turn the pump at a given number of RPMs, and then we're going to rely on these gauges and meters, and you're going to see some adjustments happening here, which this is the back of the button and the idle springs, and you saw the button go in here. Fuel screw is down the center of the throttle shaft, so you may see adjustments there, and then these stops on each side of the throttle shaft. So that's about it. We'll step you through and film some of this calibration process on a PT pump. You're talking maybe 30 minutes. We'll step back and get some footage. We'll probably just speed you up. You can't hear anything when we're doing it in here. We'll walk through this and show you some of calibration.
When I first fired up and trying to get all the air out of it, I had both these valves open. And that's just to make sure I'm getting all the air out of it. Around to RPMs.
Cranking that wheel there, pick up some RPMs.
So 1300 is one of our specs. I'm going to shut this valve off. I'm going to use this as a flow control valve. I'm going to try to set the, it's supposed to be a 390 to spec. This is just to give us an idea of kind of where we're going to be. So I'm going to set it close to that. Now I'm going to set my throttle leakage. I'm going to run it up to 2100 and set that with this. For 110 right there. That's my throttle leakage. Okay. I'm gonna back down. And I noticed when I was doing that, before I got to 2100, it started coming back. So I'm gonna have to add some shins to it probably. But remember, I took some out.
Yeah.
So now we're going to stop it. I got my gauge. So this side's set. That's my throttle leakage. Now I'm going to put this gauge on. And I'm going to travel 28 degrees because that's how far the lever should travel. And we're going to set this stop at that. Okay. Alright. So read this. 5, 10, 15, 20, 25, 26, 27, 20. Okay, that's pretty far past. So we're going to screw this in a little bit. Alright. 5, 10, 15, 20, 25, 26, 27. Okay, that looks good enough to me. That's full.
That's wide open.
Idle's back here. Yeah.
Okay. So you're setting how far the lever can move from the idle position to the wide open position.
Right.
28 degrees from.
With their linkage and stuff, they're only allowed. They're only allowed to travel so far, and they don't want it too far. You'll be pressing on it. Or too short, you'll be pressing on it too hard.
Right.
So I'm gonna start it up. Okay, this idle's open. This is closed. So we're gonna read idle. 630 is the spec. We're gonna go to 680 because we always go 50 RPMs higher. 680. We're gonna pull it back, and we're reading this flow right here. So we need to be at 210. Take this controls that screw in that assembly pack, so we're going to screw it in to get that flow to come up. Once we have it set about where we want it, we're going to pull it out so it's not doing anything anymore. And when I dial this RPM down, the fuel should go up. When I move the RPMs higher, it should go down lower. It is. So we're working correctly. Everything's working on there. Go back to 680. Should be at 210. Next, I'm going to close that off. I've basically got idle set and leakage and travel both set already. The next thing we're going to hit auto governor 2130 to 2150. This gonna go up, 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 and the minute it drops back one, that's hitting governor breakaway. See right there? We're hitting it like 20-20 probably. Okay, so we need to be at 21-30, so we're like 100 off. And each of those shims is like 20, represents about 25 RPMs. And earlier I took out 4 shims, so that's like 100 RPMs. So that's probably where I need to be. Now what I'm gonna have to do is take this cone off and bring them shims in here and put them back in.
All right, so what you just saw there, he was turning the pump faster and faster and faster, and he was watching this pressure gauge. The pressure gauge started to fall back off at about 2,020 RPMs, which means we're hitting red line before we should. So he ought to be able to run that RPM up to 2,100 before he sees the governor start pulling fuel back away. And what we do to adjust that is take the cone off the back of the pump. We talked about earlier those shims. We fought getting some of those shims in there. It looked like there was a pretty ridiculous amount, but it was probably right on. So he was saying, I don't know if you could hear him, we stole about 4 shims out of it. Each shim's good for about 25 RPMs. So we're going to take that back apart. We're going to re-shim it up, adding tension to the spring, and then we're going to see where our cutoff comes in.
So I'm adding them 4 shims back. Now we're going to try to get them fit in here. I probably should have added even one more. Since this gives me 100, we'll still be at 2120.
What was spec?
2130 to 2150. Alright, I got them in there though. That just seems like an awful lot of shims to me. So. I don't normally have, sometimes you don't even have to have shims, and that's a lot. So we'll see what happens though. That should have brought me up around 100 RPMs, maybe a little more, a little less. Really, I should have done it when we were up to 100, but I was still talking. That made me scream. Now I'm going to go back up there. So we're at 220, 2100, 7 inches of capacity. Now we're at 152, 1500, 5 inches HP. This is at 2125. This is at like 2440, 15. 110, 28. I set this 210 at 680. So that's hot. That's more than 25% up. 25% would be like 45 added onto there. So I'd be at like 1 plus push. That's where we're going to set. The last thing I do, I'm going to run it up Shut power off, and it should stop. Run it, and shut the power off. Everything stops. And then you can't turn it back on while it's going, but it switches stopping. It's doing the same thing. So we know that's working.
Calibration and verification of your Cummins PT style pump. We're about 25%, probably a little bit more than 25% over the factory calibration specs for this pump. Normally we would stick a tamper-proof plug in the end of the throttle shaft, which would prevent someone from getting to the fuel screw. In this situation, we're going to leave that open for Matt. If he wants to tamper with that at his own risk, he's more than welcome to. In this pump, turning that screw out is going to be more, and one turn would be a bunch. If you were going to play with that screw that you should never play with, maybe half a turn, quarter turn, take baby steps, keep track of where you're at, but again, don't ever mess with that unless you want to. So that's it, right? You saw us run the pump up, and when we got to 2100 RPM, 2150 or whatever it was, you saw the governor start to pull fuel back away. That's to keep your engine from blowing up. You watched us check it at 680 RPM, which is where we set the idle spec. Again, at idle, we were measuring for flow instead of pressure, but we were watching this. I think we were getting about that 35 or whatever we said. We were able to run this pump up, I think, almost to 280 psi, which is danger zone, makes us nervous. We ended up setting it about 220, which is going to be a pretty good increase over the stock calibrations. Everything ran off perfect. You watched us verify that the shutoff solenoid is working. We went through all the different steps and everything checked out just fantastic. We're going to pull it off of here, give it one last bath. We'll get it a paint job. We will serialize and part number this pump so that we know who did what and when and how the calibration went off. We'll meet you at the parts counter.
Here it is. So we brought you through the process. You watched it come in greasy and grimy. We cleaned it up, disassembled it, inspected it, machined it, honed it, rebuilt it, calibrated it, painted it, and we're back at the parts counter with another successful repair at Area Diesel Service. This pump was actually, looked like it was probably in perfectly fine working order. It did show some wear, but it basically got the full service just like all of them always do. The repair to these is fairly standardized, and we always give them the full treatment. We didn't really find a tremendous amount wrong. Usually what we do see, probably the number one most common thing, is they've sat around with bad fuel or biofuel, or they've sat for so long that they're gummed up. And usually the first thing we do is pop this cone off, and you'll find it packed full of shmoo, and you know then it's going to be gummed up internally. It doesn't change much. The whole pump always comes apart. The whole thing always gets cleaned. The other common thing we see is they'll come in, they'll pull the whole pump and send it in, and the only thing that's really wrong is the solenoid. This is certainly a field serviceable component. 2 screws. These are inexpensive and readily available, but we do see a lot of repair and returns that could have been fixed in the field with a solenoid. So the other thing that you'll see a lot of is wear on these shafts. So you saw us hone and size a couple of bushings in the main housing back in the machine shop. And when the bore and or the shaft wear, then governed fuel is allowed to bypass around them, and you'll get excessive pressure out of the pump when you don't want it. So the common symptom is you fire this thing up and it just bang, it's at 1200 RPM and there's nothing you can do to bring it down. And that's a pretty common sign of wear on these shafts and or their corresponding bushings. So this thing got the full service. Really, it was just here while he was doing an overhaul. We just wanted to have a look, make sure it was good, take care of any issues before they come up, make sure that he's got a good pump moving forward. Nothing abnormal at all. The pump was actually really clean, and it was what I would call a standard overhaul for this pump. Hopefully, after following through the repair and specifically the calibration and watching how this thing operates on the test stand, maybe you've gotten a better idea of how it is that this pump governs the engine speed. Again, variable pressure supply pump, and it's operating on this passage right here. So in this injector, there's a specifically sized metered orifice, and based on the pressure coming out of this pump is what dictates how much this injector gets charged before the camshaft comes around and powers and delivers that into the cylinders. A much different way of delivering fuel and governing an engine. When we've done some of these other pumps, you've watched us calibrate for specific cylinder quantities of fuel, right? And we didn't do that on this one. This one was pressure and flow. One thing I mentioned before, I likened this to kind of the first common rail pump. It is a supply pump of fuel to a common rail, but one thing that's dramatically different, we talked about the range of pressure. We were like 35 to 200 psi or whatever the specs were, right? Modern common rail, you're talking 30 or 40,000 psi. Maybe conceptually similar, but as far as technological advancements, wildly different pressures. Still a pretty amazing feat to think about the design and development and engineering of this pump. I don't remember when this thing first came to exist. 50s or 60s perhaps was when this thing was first designed and deployed. You know, how they engineered and designed and developed this thing back in the day is kind of fascinating to me. So pretty neat little contraption, and hopefully you enjoyed watching us go through it. A couple of things we didn't really hit on. If you go on a much higher horsepower specification, like maybe a KT 1150 or a significantly higher rated engine, this gear pump that we looked at, so this is a 3/4 inch gear pump. You can actually upsize this. Common upgrade would be to a 1-inch gear pump. That's one thing that we didn't really hit on. You might be able to get the pressure, but if you can't get the volume, you've got to jump up to a different size gear pumps. The other thing that we talked about was the button upgrade. This pocket right here is the area that the fuel pressure is being allowed to operate on to push it back against the springs. When you change your button, this is number 5, so this is the smallest or highest power button, and then this one is a 55. Pretty dramatic, both ends of the spectrum there. That is the common upgrade to the PT style pump, and then the other one that we talked about was the screw that you should never adjust down inside the throttle lever. Don't ever turn that out for more fuel. And then throttle lever, this came in loose from the pump, and we're going to send it back out that way because we don't know the orientation. If it would have been on there, we would have marked it, but we're going to leave that to Matt. Drive isolator and flange gasket go with it as per usual. And then we don't do them here. I know we mentioned that before, but we've got a set of remanufactured injectors for this project of Matt's. These are very high quality Reman unit. We've got a 6er packed up for him there. Area Diesel swag, a couple of hats, a couple pairs of gloves. We're going to send a banner. Hopefully Matt's got some space on his new shop walls. I know he's got some bare canvas there. That's about it for this project. The $1 million question, what did this cost? This is a 5-hour project at $1.25 an hour. $6.25 for labor, plus a couple $100 in parts. The injectors were $713 there. So pump and injectors, $1,538 out the door. We assign a range of I think $700 to $1,000 to repair and return a PT pump. We've got a bunch of these cores, so we can also offer them as an exchange. We actually stock some of the common calibration codes. We can build almost all of the relatively common PT or AFC or VS style Cummins pumps. That's a wrap. If you didn't come to us from Matt's channel, please be sure to go over there, check him out, watch this hardware get installed. Once he gets this thing up and running, perhaps there'll be a turbo in his future. He's got a functioning HT4C right now, which is kind of an antiquated dude. So we're going to see how that goes and performs, but perhaps we'll get a turbo in here in the future. If you need anything, please don't hesitate to reach out to us and let us know. You can call us at 800-637-2658. You can drop us an email at parts@areadiesel.com. You can log on to our website at areadieselservice.com, where you'll find a large amount of high quality information and the ability to chat instantly with a diesel engine expert through the button in the bottom right hand corner of your screen. Or you can stop by any of our locations in Iowa, Illinois, or Indiana. You could reach out and leave us a review on the Googler. So that's it. Thanks for watching.